ਹੈਲੋ ਡੀਅਰ ਸਟੂਡੈਂਟਸ, ਉਮੀਦ ਹੈ ਤੁਸੀਂ ਸਾਰੇ ਖੁਸ਼ ਹੋਵੋਗੇ ਅਤੇ ਆਪਣੀ ਪੜ੍ਹਾਈ ਵਧੀਆ ਤਰੀਕੇ ਨਾਲ ਕਰ ਰਹੇ ਹੋਵੋਗੇ। ਜ਼ਿੰਦਗੀ 'ਚ ਕਾਮਯਾਬ ਹੋਣ ਲਈ ਤੇ ਜ਼ਿੰਦਗੀ ਨੂੰ ਵਧੀਆ ਢੰਗ ਨਾਲ ਖੁਸ਼ੀ-ਖੁਸ਼ੀ ਜਿਉਣ ਲਈ ਸਭ ਤੋਂ ਵੱਡਾ ਰੋਲ ਹੈ ਸਾਡੇ ਨਜ਼ਰੀਏ ਦਾ, ਸਾਡੇ ਐਟੀਟਿਊਡ ਦਾ, ਸਾਡੇ ਦ੍ਰਿਸ਼ਟੀਕੋਣ ਦਾ। ਇੱਕ ਵਾਰ ਇੱਕ ਗੁਬਾਰੇ ਵੇਚਣ ਵਾਲਾ ਇੱਕ ਮੇਲੇ ਦੇ ਵਿੱਚ ਗੁਬਾਰੇ ਵੇਚ ਰਿਹਾ ਸੀ ਤੇ ਬੱਚਿਆਂ ਨੂੰ ਅਟਰੈਕਟ ਕਰਨ ਵਾਸਤੇ, ਆਪਣੀ ਸੇਲ ਵਧਾਉਣ ਵਾਸਤੇ ਉਹ ਅਲੱਗ-ਅਲੱਗ ਕਲਰ ਦੇ ਗੁਬਾਰੇ ਰੈੱਡ, ਬਲੂ, ਗ੍ਰੀਨ, ਯੈਲੋ ਹਵਾ 'ਚ ਭਰ ਕੇ ਛੱਡ ਰਿਹਾ ਸੀਗਾ। ਇੱਕ ਬੱਚਾ ਉਹਨੂੰ ਦੇਖ ਰਿਹਾ ਸੀ ਤੇ ਬੱਚਾ ਉਹਦੇ ਕੋਲ ਆ ਕੇ ਪੁੱਛਦਾ, ਅੰਕਲ ਤੁਸੀਂ ਰੈੱਡ, ਗ੍ਰੀਨ, ਬਲੂ ਇਹ ਸਾਰੇ ਗੁਬਾਰੇ ਛੱਡੇ ਨੇ, ਕੀ ਬਲੈਕ ਕਲਰ ਦਾ ਗੁਬਾਰਾ ਵੀ ਉੱਡ ਸਕਦਾ ਹੈ? ਤਾਂ ਉਸ ਗੁਬਾਰੇ ਵੇਚਣ ਵਾਲੇ ਨੇ ਬੱਚੇ ਵੱਲ ਦੇਖਦੇ ਹੋਏ ਬੜੇ ਪਿਆਰ ਨਾਲ ਕਿਹਾ ਕਿ ਬੇਟਾ ਇਹ ਇਸ ਕਰਕੇ ਨਹੀਂ ਉੱਡ ਰਿਹਾ ਕਿ ਇਹਦਾ ਰੰਗ ਬਲੂ, ਗ੍ਰੀਨ, ਯੈਲੋ ਜਾਂ ਰੈੱਡ ਹੈ, ਪਰੰਤੂ ਇਸ ਕਰਕੇ ਉੱਡ ਰਿਹਾ ਹੈ ਕਿ ਇਹਦੇ 'ਚੋਂ ਗੈਸ ਭਰੀ ਹੈ, ਉਹ ਇਹਨੂੰ ਹੈਲਪ ਕਰਦੀ ਹੈ ਉੱਡਣ ਦੇ ਵਿੱਚ। ਇਹ ਡਿਪੈਂਡ ਕਰਦਾ ਹੈ ਕਿ ਇਹਦੇ ਅੰਦਰ ਕੀ ਭਰਿਆ। ਸੋ ਇਹੀ ਚੀਜ਼ ਸਾਡੀ ਜ਼ਿੰਦਗੀ 'ਚ ਅਪਲਾਈ ਕਰੀਏ। ਇਹ ਡਿਪੈਂਡ ਕਰਦਾ ਹੈ ਤੁਹਾਡੀ ਕਾਮਯਾਬੀ ਕਿ ਤੁਹਾਡੇ ਅੰਦਰ ਕੀ ਭਰਿਆ ਹੈ। ਉਹ ਹੈ ਤੁਹਾਡਾ ਐਟੀਟਿਊਡ, ਤੁਹਾਡਾ ਨਜ਼ਰੀਆ, ਤੁਹਾਡਾ ਦ੍ਰਿਸ਼ਟੀਕੋਣ। ਸੋ ਮੇਕ ਯੂਅਰ ਐਟੀਟਿਊਡ ਪੋਜ਼ਿਟਿਵ because your attitude contribute towards your success. So ਇੱਕ ਬਹੁਤ ਵਧੀਆ ਪੋਜ਼ਿਟਿਵ ਨਜ਼ਰੀਆ ਲੈ ਕੇ ਅੱਜ ਆਪਾਂ ਇੰਜੋਏ ਕਰਦੇ ਹੋਏ, ਮੋਟੀਵੇਟ ਰਹਿੰਦੇ ਹੋਏ ਸਟੱਡੀ ਕਰਾਂਗੇ ਫੋਰਸ ਐਂਡ ਲਾਜ਼ ਆਫ ਮੋਸ਼ਨ। ਸੋ 10-15 ਮਿੰਟ ਮੇਰੇ ਨਾਲ ਰਹੋ ਔਰ ਇਹ ਲਾਜ਼ ਆਫ ਮੋਸ਼ਨ ਤੁਹਾਨੂੰ ਬਿਲਕੁਲ ਸਮਝ ਆ ਜਾਣਗੇ। ਸੋ ਡੋਂਟ ਵਰੀ, ਬੀ ਹੈਪੀ। So first of all, what is force? Force means simply, you all know, it is a push or pull, which when acting upon a body moves it or tends to move it. In other words, we say that force is an external agent, which when acting upon a body produces or tends to produce acceleration in the body. So force is a vector quantity and is given by this formula F is equal to ma. We will derive this formula later on. Then linear momentum. Linear momentum is the measure of quantity of motion and it is equal to the product of mass of the body and velocity of the body. In SI system, when mass is 1 kg, velocity is 1 meter per second, unit of momentum is kg meter per second. In CJ system, when mass is 1 gram, velocity is centimeter per second, then unit of momentum is gram centimeter per second. Now, we have three quantities: momentum, mass and velocity. Suppose when velocity is constant, for a fixed velocity, momentum and mass, graph between momentum and mass comes out to a straight line. That is, more is the mass of the body, more is the linear momentum. Similarly, when mass is kept constant for a body of given mass, momentum is directly proportional to velocity of the body. And for momentum is kept constant, velocity and mass graph comes out to be a curve like this. It means when momentum is kept constant, heavier is the body, less will be the velocity attained by the body. So it means when momentum is constant and we have two bodies of unequal masses, say m1 and m2, having speeds v1 and v2, then m1 v1 must be equal to m2 v2, or v2 upon v1 is equal to m1 upon m2, or v is inversely proportional to m. So this proves that heavier is the body, lesser is the velocity, provided momentum is constant. Now, then Newton's first law of motion. Newton's first law of motion states that every body continues in its state of rest or uniform motion along a straight line until unless it is compelled by some external force. In other words, body is unable to change its state of rest or uniform motion along a straight line without the application of external force. So this means this law is nothing but it gives qualitative definition of force, quality of force. It is also known as law of inertia. Now, what is inertia? The inability of the body to change its state of rest or uniform motion along a straight line by itself is called inertia. Inertia is of three types. Inertia of rest. Inertia of rest is defined as the inability of the body to change its state of rest by itself. For example, when we are standing in a bus and bus suddenly starts moving, we feel a backward push or jerk due to inertia of rest. Because when bus comes into motion, our feet, which are in contact with the surface of bus, they come into motion, but upper part of body remains at rest. That's why we feel a backward push. Second, inertia of motion. The inability of the body to change its state of uniform motion along a straight line by itself is called inertia of motion. For example, we are standing in a moving bus is moving, and when brakes are applied suddenly, that is bus stops suddenly, then we feel a forward push or jerk. Sometimes we fall down. This is due to inertia of motion, because when bus stops, our feet, which are in contact with the bus, comes to rest, but upper part is still in motion. That's why we feel a forward jerk. Third is inertia of direction. The inability of the body to change its direction of motion by itself is called inertia of direction. For example, when a car or bus takes sudden turn towards left at the turning point, we feel a push towards right due to inertia of direction. So inertia depends upon mass of the body. More is the mass of the body, more is the inertia. Then we come to Newton's second law of motion. Newton's second law of motion, it states that the rate of change of linear momentum is directly proportional to the external force acting upon the body, and it takes place in the direction of force. Therefore, if we have a body upon which force is acting and body is being accelerated with acceleration A, let u is equal to initial velocity of the body, v is equal to final velocity of the body, then initial momentum will be m into u, where m is the mass of the body. Final momentum will be m into v. Then change in momentum, final momentum minus initial momentum, that is mv minus mu. Therefore, rate of change of momentum is equal to change in momentum mv minus mu over time taken. T is the time. Now, by Newton's second law of motion, this rate of change of linear momentum is directly proportional to external force. So let it be F. So F is proportional to m into v minus u upon t. But v minus u upon t is equal to a from first equation of motion. So therefore, F is equal to kma, where k is a constant of proportionality. Its value is so chosen that when a is equal to 1 unit, m is equal to 1 unit, F is taken to be 1 unit. Therefore, k is equal to 1 or F is equal to m into a. This is the fundamental equation of motion. Force is equal to mass into acceleration. Now, from this equation, we can define units of force. First is in SI system, unit of force is Newton. So when mass is 1 kg, acceleration is 1 meter per second square, then force is said to be 1 Newton. In CJ system, when mass is 1 gram, acceleration is 1 centimeter per second square, then force is said to be 1 dyne. and 1 Newton is equal to 10 raised to power 5 dyne. So this is second law of motion. Then Newton's third law of motion. Newton's third law of motion states that to every action there is an equal and opposite reaction. That is, action is equal to minus reaction. But they do not cancel each other. Even action and reaction are equal and opposite. Then why they do not cancel each other? Because they act upon two different bodies. For two forces to cancel each other, they must act upon the same body. For example, when a block is lying on a table, then this block is applying action on the table in the vertically downward direction, whereas table is applying reaction on the block in the vertically upward direction. So they are acting upon two different bodies. So they do not cancel each other. So this is Newton's third law of motion, that is F12 is equal to minus F21. Action is equal to minus reaction. So from this Newton's third law of motion, we can also conclude law of conservation of linear momentum, which states that if no external force is acting upon a system or body, then total momentum of a system or body remains conserved or constant. That is, if F is equal to 0, then from this equation mv minus mu is equal to 0. It means mv is equal to mu or p1 is equal to p2. That is, initial and final momentum are equal. This is known as law of conservation of linear momentum. For example, to explain third law of motion and law of conservation of linear momentum, take the example of recoil of a gun. So when gun is fired, it applies action on the bullet, and as a result, bullet applies reaction on the gun. That's why gun kicks back or gun recoils. So action is equal to minus reaction. Now, before the gun is fired, bullet and gun both are at rest. Therefore, net momentum of the system is 0. Total momentum of the system is 0. But when gun is fired, suppose bullet moves with a velocity small v and having mass small m. That capital V is equal to velocity of recoil of the gun in the backward direction. Capital M is equal to mass of the gun. Then by law of conservation of linear momentum, mv plus mv, capital MV, must be 0, because total momentum before the firing must be equal to total momentum after the firing. So therefore, mv plus mv is equal to 0, or capital M into capital V is equal to minus mv, or capital V is equal to minus m upon m into v. So this capital V is known as velocity of recoil of the gun. But velocity of recoil of the gun is very small as compared to velocity of the bullet, because mass of gun is very large as compared to mass of the bullet. So this is Newton's third law of motion and law of conservation of linear momentum. Now both Newton's first law of motion and third law of motion are the consequences of Newton's second law of motion. In other words, Newton's first law of motion and Newton's third law of motion can be obtained from Newton's second law of motion. So Newton's second law of motion is the only real law of motion. For example, what is Newton's second law of motion? F is equal to ma. Now if A is 0, means acceleration is 0. If force is 0, then A is 0. It means because m is not 0. If acceleration is 0, it means velocity is constant. Means if body is at rest, velocity is 0. If body is motion, velocity is constant, which is nothing but Newton's first law of motion. Every body continues in its state of rest or uniform motion along a straight line unless it is compelled by some external force. So force is zero, there is no change in velocity. Body at rest remains at rest, body in uniform motion remains in uniform motion. So this is all about laws of motion. I think it's very simple and you have understood each and everything. If you have some problem, then please watch my video 2 or 3 times and you will get everything and enjoy your life. Stay tuned for next video. All the best. Sarvada Pala. Thank you.